Welcome to PGSMaths. In this video I will be looking at the angle properties of triangles. A triangle is a shape with three straight sides, but there are different types of triangles, each with their own properties. The first of these is the equilateral triangle. Now, the equilateral triangle is very special. It's an easy one to remember because it has two very unique properties. Both of these properties can be seen if we start to look at the shape from different sides. If I rotate the triangle, it still looks the same. The angle at the top, look carefully, compare it to the angle at the top now. It's exactly the same. How about the length of the sides? They're also equal. So all the angles in an equilateral triangle are the same, and all the sides are the same length. If we put these triangles next to each other, we can also find a very interesting property. These triangles fit very nicely together because the lengths are the same size, but they create a straight line. Now, a straight line, we know, equals 180 degrees. So if we know that this angle is the same as this angle, and is the same as this angle, then they must each equal 60 degrees. In an equilateral triangle, each angle is always 60, and that's a very important fact to remember. But does that make the equilateral triangle unique? Because they're all 60, the angles add up to 180. So is that something special about an equilateral triangle? Let's have a look at a different triangle, and this time we're going to look at the scalene triangle. A scalene triangle has three different angles and three different length sides. But does it have any similar properties to an equilateral triangle? Well, if we place the same size triangles next to each other, we can see that they still create this straight line. So it doesn't matter what type of triangle you have, they will always create this 180 degree line. Which means that if you add together the three angles inside a triangle, it will always come to 180 degrees. And we're going to use that fact to try and find some missing angles. If you're given two angles in a triangle and asked to find the missing one, all you need to remember is that they have to add up to 180 degrees in a triangle. So how do we use that fact to find this missing value? Well, we know that the two angles here add up to 70, because 40 add 30 equals 70 degrees. So to find this missing angle, obviously whatever is left over from this 70 degrees must be the value of this angle. So we do 180, which is the total, take away 70, which is the two angles we know, and this adds up to 110 degrees. So our missing angle is 110 degrees. It doesn't matter what numbers these are, as long as they are less than 180 when put together, it's a triangle and we can find the missing value. Now, there's one type of triangle we haven't looked at yet, and that's called an isosceles triangle. Again, the isosceles triangle is special because it has two very unique properties. We know that the angles have to add up to 180 degrees because it's a triangle. But the things that make the isosceles triangle special are that two of the sides are the same size, they're the same length. And this is usually shown by a line, or sometimes two lines, on the two lines which are equal. This indicates that the two sides are of equal length. Kind of makes it look a little bit like a cat. The other unique property of an isosceles triangle is that the two base angles are the same as well. Now a base angle is formed at the bottom of these two equal lines. So in this case, there's one angle here on the bottom left and one on the bottom right. These are both exactly the same, making the isosceles triangle completely symmetrical. We're going to use this second property to find missing angles in an isosceles triangle. Things get a little bit harder here, but we can solve this with only one angle. Once again, because it's a triangle, we automatically assume that the total number of degrees in the whole shape is 180 degrees. But how do we find this top missing angle? Well, to do that, we need to know what the bottom right angle is. It's not written on, but what we have here are two base angles. They're at the bottom of these equal length lines, so therefore this angle here must also be 70 degrees. They're identical to each other. So now we know two of our angles, we can find the missing one. 70 add 70 is 140. So the missing angle to make this add up to 180 can be found by taking 140 away from 180, leaving us with 40. So our missing angle in this problem is 40 degrees. But what happens if we only know the top angle? Well, the total number of degrees doesn't change. Always 180. Always write that down when you're dealing with a triangle, because 9 times out of 10 it'll help you. So in this diagram, we've turned the triangle round a little bit. Our two equal length lines are on the left hand side. And what that creates are base angles at the top and bottom. Problem being that because we don't know one, we also don't know the other one. But because these are both the same, it must be half of whatever's left over from 180 if we take away 40. So 180 take away 40 equals 140 degrees, just like in our last question. So these two angles add together to give 140. Well, if they're both the same, then all we need to do is to take that missing angle and half it. So if I divide it by 2, I find that each of the missing angles is 70 degrees. Now, does that look like 70 degrees? Does that look like 40 degrees? No. Most of the time, diagrams like this will not be drawn to scale, so pay attention to the numbers and pay attention to the facts. They're the important ones, they're the ones that will allow you to answer the problem. The final challenge of the day is taken from this diagram here. Terry thinks it's impossible to find angle Y without measuring it. Can you prove her wrong? Put your answers in the comments section below. Remember to subscribe to the channel for future videos, and send me a message on PGSMaths on Facebook or at PGSMaths on Twitter if you have any future problems or requests for videos. I'll do my best to try and answer questions.